morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are talking about three-dimensional problems. Let's get to it, shall we? Okay, as you can see, we got some three-dimensional figures here, and within them, often, we have some right triangles that we can use to help us answer some questions, particularly some application problems. We'll do a couple right here. We have a cylinder, 50-meter rope is attached inside an empty cylindrical wheat silo of diameter 12 meters as shown. How high is the wheat silo? All right, well, if you just cut out a slice of the silo, the cylinder, hopefully you can see you got yourself a right triangle here. So this goes here, this goes down. This goes down like that, little too fur. We've got a right angle. This is 12 meters right here. It's equal to the diameter of the cylinder. And the hypotenuse is 50 meters. And then the height of the cylinder is right here. I'll call it X, which corresponds to this side of the triangle. So I simply use the Pythagorean theorem. Excuse me. And I can say that x squared plus 12 squared is equal to 50 squared. So x squared plus 144 is equal to 2500. If I subtract 144 from both sides, x is equal, or x squared is equal to 2500, 2400. So that's going to be 2356. So x is equal to the square root of 2356. Let's check all that out on the calculator. Let me just add a calculator page. Good. And then we'll take the square root of that. Control square root 2356. Enter, and that is about 48.5 meters. So we'll say, what was it? About 48.5 meters. So we'll say that's approximately equal to 48.5 meters. Now, I've said in the past, I don't mind if you leave things as in the form of a square root. But when you're talking about application, there's nobody who runs around and says, well, that silo is a square root of 2356 meters. We would say, it's 48.5 meters tall. So for this instance, when it's an application, you really do need to use your square root and get an estimation there. Okay, one more question, I think. Floor of a room is 6 meters by 4 meters and its height is 3 meters. Find the distance from a corner point on the floor to the opposite corner point on the ceiling. So what we have here is a square room, and I'm going to try and draw a nice one for us here. Let's see, there's a rectangle, and I'll start off with the front of the room, and then I'll draw some edges, okay, like right there, right there, right there. Doesn't have to be perfect, mine's looking pretty nice here, right here, then maybe right here. And then I'll change this to dash to do the hidden lines. So like maybe here in the back, here up top, and then here. Okay. So we have our room. It's rectangular. Let's go ahead and label it. And it says it's 6 meters. So this would be a 6 by 4 meters by 3 meters. Find the distance from a corner point on the floor to the opposite corner point on the ceiling. So what they're looking for is this distance here. So from a corner point on the floor, so I'll choose this one, to the opposite corner on the ceiling. So that's all the way up here. Okay. So think of a diagonal going through a room. Well, I'm going to go ahead and draw this right here, just to show you that if I had that triangle, okay, this one right here, it would look something like this. Bam. And I would know, since the height is 3, this is also 3. I know that this is 3. And I'm looking for this, which is x. I'll put the x right here. And I'm going to call this part y, this length right here. Well, if I knew y, I would be easily able to solve for x using the Pythagorean theorem. Well, I can find y because the bottom of the floor is also a rectangle, okay? And there's a right triangle lying down on the floor here, okay? Lying down on the floor. So I'm going to draw that one in an upright position. And I'm going to say, or just relabel it, this side is this bottom part right here, 6. This side is this side right here. And then the hypotenuse is the y. So if I solve for this y, I can substitute in here, and then I'll be able to easily solve for the x. So let's go ahead and do that. And that would be 6 squared plus 4 squared is equal to y squared. So 36 plus 16 is equal to y squared. Let's see, 36 and 16, 46, so 52 equals y squared. So that means that y is equal to the square root of 52. And we'll leave it like that. So putting that in here, that equals root 52. So now I can say that, using this triangle, 3 squared plus root 52 squared is equal to x squared. So 9 plus the square root of anything squared is the anything. So the square root of 52 squared is the 52. That equals x squared. So 61, 52 plus 9 equals x squared. So the square root of 61 is equal to the length, the distance from one corner, the bottom corner, to the opposite corner on the ceiling. And since it's a distance, we probably should get an estimate for that. So let's do control square root 61, and we get about 7.81 meters. So we can say that 7.81 meters is approximately equal to x. And that is all I have. So with 3 dimensions, you just have to do some careful drawing, and it turns out into some nice and easy right triangles, and we can use the Pythagorean theorem. And with that, I am out.